Dispenser going up.
Transformations. Verifying properties of rotation, reflection, and translations. Utilizing the properties of rotation, reflection, and translations to model and relate pre-images of lines describing a sequence of transformations. The exhibit congruency. You will also be describing the effects of dilation, translations, rotations, and reflections on two-dimensional figures using coordinates. Using coordinate planes to locate pre-images of two-dimensional figures and determine the coordinates of a resultant image after applying dilation, rotation, reflection, and translations to the shape. Knowing this knowledge, you'll be able to draw a transformed figure using the given rules and drawing the result of that sequence of rotations, reflections, and translations. Transformations that will carry a given figure onto another. Knowing this knowledge, you will be able to do this to the image. You'll be able to reflect it over the y-axis or x-axis. You'll be able to rotate it any degrees, and you can also translate it. Like example, a equals 2 by negative 1. You will be like translated 3 units to the left or something like that. Then the y-axis will be a different number. Also, you'll be able to do dilation. Dilation will be when you make a shape smaller than its original state or larger.
Hey guys, it's Sam here, and I'll be doing Unit 2 functions. To start it all off, a function is a relationship between a set of inputs and a set of outputs. For each input, there's exactly one output. If it has two of the same outputs, then it is not a function, it's some other thing. There are different types of ways that you can show data, such as tables, bar graphs, column graphs, line graphs, pie charts, motion charts, or plotting with script or 7-leaf plots, or tables, or vertical tables. And each way shows the exact same data but in a different perspective. Some may be visual, some may be more numerical, and yeah. The next thing is about functions, where about f of x, where f corresponds to the input, which is x, such as it's read f of x. Let's say the input is -3 and the output is 9. We may write, you can write this statement as f of -3 equals 9. The rate of change is the steady pace of the table or whatever. Let's say my input is 5 and my output I get is 10, and my second input I have is, let's say, 6 and the output is 12. The rate of change is times 2. Or other examples we can have is a more complicated rate of change, like 1.5. Like with the same example, my input is 5, but this time my output is 7.5, and my other input is 6, and the output is 9. This time the rate of change is different. It's 1.5. It's still at a steady pace. The next thing we'll be talking about is a slope intercept form where y equals mx plus b, and where m is the slope and b is the y-intercept. It is also commonly known as the rise over 1, or the change in y equals the change in x. One way, and I prefer this, the best way to find the slope intercept form on a graph. Make sure it only works if it has boxes, and I'll put a picture of the thing right now. As you see, the point A is plotted at 0, 2, and point B is plotted at 5, 5. You go up 3, which is the rise, and you go right 5, which is the run. If you went left, it would be a negative, and if you went down, it would be a negative. And as you can see on the graph.
Linear equations. Graph proportional relationships interpreting the unit rate as the slope of a graph. Compare two proportions relationships represented in different ways. Similar triangles to explain why the slope ms, the same between any two distant points on a non-vertical line in the coordinate plane, driven the equation y equals mx for the line through the origins and the equation y equals mx plus b for the line intercepting the vertical axis at b. Y equals negative 2/3 x. Solve the linear equation in one variable. Negative 3x plus 7 equals 5.
Hi guys, it's Tanvi here, and today I'll be showing you how to do Unit 4 exponents. The first objective we'll be looking at is 8.ee.1, which basically shows that we know how to apply the properties of the integers and stuff, integer exponents, and use them in equations. First I'll also be covering a.ee.3, a.ee.4, and a.g.9. Right. First we'll start off is with the rules. There's some of the rules are that the product rules. Alright, this is for regular exponents or any type of exponents in general. Let's say you have an times am. The extra variables are the exponents, right? So in order to get the answer, you put the base number, which is a, and you would add and m together, then you would get your thing. And I'll put a picture of the rules too, as for each of them. I'll put like a picture up there too if I can. Also, the quotient rules, this is the same thing. It's when you divide them. But the only difference is you subtract the exponents. Right? The regular power, the negative exponents, which is, let's say you have 2 to the negative third power, right? It would basically equal, it would become a fraction, right? The fraction would basically become 1 over 2 to the third power, which if you make it to a decimal will be 0.125 or 1/8. Okay. The zero rules is if anything with a zero exponent will always equal 1. So 5 to the 0 power is 1. The 1 rule is anything that's the exponent is 1, it would equal the base number. So 5 to the first power would be 5, and 1 to the fifth power would be 1. And the next thing we'll be talking about is scientific notations. Scientific notations is basically a shorter way of writing big numbers. Let's say you have 2 times 10 to the second power. It's basically saying 2 times 10, or another example would be 5.6 times 10 to the negative ninth power. Is basically saying that 0.000 like 9 times, then 56 again. Also, um, if the exponent in the scientific notation is a positive one, then it will be the exact same thing as I said before, but this time it will be it wouldn't have decimals, so it would be 56 and you add all the zeros at the end. The next thing we'll be talking about is the volume. The cylinder equation is volume equals pi times r squared times height. And keep in mind that sometimes they'll ask you to write in pi, or they'll ask you to write it in total. If they ask you to write in pi, you ignore the pi part and you just write pi, like the pi symbol, at the end of your answer. And they actually do multiply by 3.14. Then you would just do the formula as how it is. The rectangular pyramid formula is volume times volume equals length times width times height, and then you divide it by 3. The volume formula for sphere is v equals 4 over 3 pi r cubed, and cube is basically you just multiply the radius 3 times, and yeah, that's the entire unit 4.
Rational. Rationals are mostly written with a represented bar that enables the mathematician to write easily. They could also be written as fractions. Example of rational fractions: 1/3 or 0.33333 and ongoing, or 4 over 9 or 0.44444 and repeating. Irrationals. These are numbers that are not repeating. Example of irrational numbers: 3.14 or negative 1 over 3. Pythagorean theorem. This is a fundamental relationship in Euclidean geometry among the 3 sides of the right triangle. There are parts of the right triangle if you are applying the Pythagorean theorem to do it. The formula is known as a to the second power plus b to the second power equals c to the second power. The base is known as a, the height is known as b, and the hypotenuse is known as c. Both parts a and b sum up or add up to the solution of c. Pythagorean triples. These are 3 integers side lengths of the right triangle, such as 3, 4, and 5, 6, 8, and 10, 9, 12, and 15, and ongoing.
Hey guys, it's Stanford here, and today we will be doing Unit 6 bivariate data. First of all, we'll be talking about scatter plots. Scatter plots are similar towards line graphs, but they aren't. It is a scatter plot it shows how one variable gets affected by another. There are positive and negative correlations, and there are no correlations at all in scatter plots. You could also tell if it's positive or negative. Sometimes it'll be easy, sometimes it'll be hard, and I'll put a picture of some of the hard and easy ones, and you could look at it. The next thing is outliers. Outliers is basically a random piece of data on your scatter plot that doesn't usually make sense with the rest of the piece of data you have collected. The next thing we'll be doing is finding the line of best fit. There are 2 ways. The first way I'll be talking about is estimating. Estimating is basically when you get a ruler and you try to find where to put the line. Usually it connects with as much of the dots you can in a straight line. The second way I'll be talking about is the actual more realistic way, which is to graph it. Not graph it, is to draw it on a graphing calculator. You would need a TI-83 or above in order to do this, and I'll put the steps on the screen right now if you guys want to look at it. The next thing I'll be talking about is two-way function tables. A two-way function table is basically a table that shows the 2 things at once. Let's say I have this function table that will be on the screen right now. Product day in January is 25, but then in February product day is 34. And as you can see in the graph, for products A through G and months January through December. The next thing is how to make a relative frequency table. Is basically the percentages or the decimals of the 2A function table. Usually it's when you get the total and you divide it by the number. Let's say my total is 100 and one of my data is 50, right? So I'll do 50 divided by 100. But since it's out of 100, you wouldn't need to divide it because it will be 50%. And sometimes they'll ask you to have restrictions. I mean, like certain circumstances, like such as how many more girls play basketball than boys, or more boys than girls, or how many boys in total, or how many girls in total. And when they ask you for a total, and sometimes they'll actually find a relative frequency for that specific section. There's also a marginal and a joint. A marginal is the total of the totals, the columns and all of that for your table, and joint frequency is the data portion.